Hello everyone, welcome to my YouTube channel. I am Engineer Ajmal. In today's video, we are going to find how to draw the shear force and bending moment diagrams of a simply supported beam under different load conditions. This video is the very first video of a series of videos in which we are going to discuss how to draw the shear force and bending moment diagrams for different kinds of beams under different load conditions. For example, in the future, we will also be making videos about the fixed beams, cantilever beams, overhanging beams, and continuous beams under different load conditions regarding how to find their shear force and bending moment diagrams. But let me tell you that this video will serve a good foundational purpose, and this video will be enough for you to understand how to draw the shear force and bending moment diagrams for literally any kind of beam under any kind of load conditions. So let us get started. So as you can see, I have drawn three beams, three simply supported beams. The first beam, a single point load is applied on it. On the second beam, 2 point loads are applied, and on the third beam, a uniformly distributed load UDL is applied. So let us get started with the first beam. So in order to find the shear force and bending moment diagrams, the very first step is find the reactions. So as we know, it is a 10 kilonewton force applied. So the reactions both will be, it's in the center. So 5 kilonewton reaction will be here. It will be divided in two parts. So 5 kilonewton will be over here. And now we need to draw the shear force and bending moment diagrams. So this line represents the zero shear force. Uh, Above it, the shear force will be positive, and below this zero line, the shear force will be negative. So there is one thing that is the foundational concept in the drawing the shear force and bending moment diagrams, and that is when we are drawing the shear force diagram, we have to look at the type of loading and the type of distribution of the load. And when we are drawing the bending moment diagram, we have to look at the type of shear force diagram. What is the shear force diagram? In simple terms, the loading on the beam will help us draw the shear force diagram, and then the shear force diagram will help us find the bending moment diagram. So let us get started. To draw the shear force diagram, we have to look at the loading. So here we see that there's a 5 kilonewton load. It is in the upward direction, so it is taken as positive in the upward direction. So we'll go 5 kilonewton in the upward direction like this, and then there is no load. When there is no load, the shear force diagram will be a horizontal straight line having a constant slope, zero slope, like there is no slope in this case. So there is no loading. The shear force line, this will go just in a horizontal manner. So again, here we have a 10 kilonewton load over here. So this 10 kilonewton is downward, so it is negative. From here we have to go down by 10 kilonewton. So from here to here it is 5 kilonewton, and then from this is the zero line. From zero again we need to come to minus 5 kilonewton point because of this 10 kilonewton load. Then between this load and the right support, there is no loading. So again the shear force line will be a horizontal straight line. So here it is minus 5 kilonewton. Again, this support, it is saying that you have to go upward by 5 kilonewton. So when we go from here to here 5 kilonewton, again it will come to the zero line. So this diagram basically shows the shear force distribution for a simply supported beam on which a point load is applied in the center. So now let us draw the bending moment diagram. Bending moment diagram. Again, this is the zero line for the bending moment diagram. Above it is positive bending moment, and below is a negative bending moment. So first we know that on a pin support and on a roller support, the bending moment is always going to be zero because it cannot resist it. There is no bending moment over here. So here it will be zero, here it will be zero. That's one thing. And now, as I already told, that based on the shear force diagram, we will draw the bending moment diagram. So from this point to this point, the shear force diagram, we have to calculate this area, and this area is equal to 5 multiplied by this length. This length is right in the center. From here to here, it is 5 meter. So 5 kilonewton multiplied by this 5 meter length, this will give us 5 by 5, 25. So this area is basically 25. So it is in kilonewton meter when we also include the units. And this area gives us 25 newton meter of bending moment. So from here to here, the maximum bending moment that is developed is 25 kilonewton. So at this point, we can write that it is a 25 kilonewton bending moment. But from here to here, how we will go, how the line will go, will it go straight or in a curve shape? That the shear force diagram will tell us. If shear force diagram is linear, is a horizontal, uh, the bending moment diagram will be a linear line straight of 1 degree. This is a 1 degree. This is, you can call it, it is 0 degree line, this one of the shear force. So the 0 degree line will convert it to 1 degree, the 1 degree will convert it to 2 degrees, the 2 degrees line will convert it to 3 degrees. Same here, there was no line, so there was no loading to 0 degree, then 1 degree. If there were like 1 degree or 0 degree, it will be 1 degree line, it will be 2 degrees. So 1 degree we have to increase as we are moving from the load to the shear force diagram and from the shear force diagram to the bending moment diagram. So again, from here to here, we have to find this area. This area is again minus 5 kilonewton multiplied by this length. This will give us the area. This is 5 meter multiplied by 5 meters, so it will give us minus 25 kilonewton meter. So again, from this point to this point, we have to go down by 25 kilonewton meter. This is 25, so if we go down, it will become 0. So from this point to this point, if we come, it will become 0. But how we have to come? We have to look at this horizontal line. This is a horizontal line of 0 degree, so we have to go with 1 degree line, a straight line from here to here. So this is again 1 degree line, and this is the bending moment diagram for this very first beam. So now for the second beam, again, first we will find the reactions for this beam. Since it is a symmetric loading, so here we will have a 10 kilonewton loading, and also here we will have a 10 kilonewton loading. I hope you understand how I'm calculating the reactions for the beams. So again, this is a zero line for the shear force diagram. Shear force diagram. For the shear force diagram, as I already told, we have to look at the loading to draw it. The loading over here is 10 kilonewton. We have to go upward, go upward by 10 kilonewton, and there is no loading, so we have to go horizontally up to this point, and then there is 10 again. We have to come downward. It was 10. When we come downward by 10, it will come to the 0 line. So this tells us the shear force diagram, and again there is no loading, so the shear force is 0, so there will be a constant horizontal line, which means that no loading up to this point, no shear force up to this point. And then at this point we have again uh, a load of 10 kilonewton in the downward direction. So from here we'll go 10 kilonewton in the downward direction, then again from here to here no loading, so it will, the shear force line will go in a horizontal way, so it is minus 10 kilonewton. And again, when it is here, 10 kilonewton will go upward. From here to here, it will go upward and it will become 0. So this is the shear force diagram over here. So as you can see, this distance is 3 meter, 3 meter, and this distance is also 3 meter. Now let us draw the bending moment diagram. This is the 0 line for the bending moment diagram. This is, in the upper direction is positive, in the downward is negative, it is again positive and negative. As we can see, like again, pin support and roller support, the bending moment is going to be 0 because they cannot resist any rotation at these supports. So now find from here to here, we have to find the bending moment, and the shear force diagram will give us the bending moment. The area of this box will be 10, is height is 10 multiplied by width 3, so it's 30. From here to here is 30, so at this point let us assume we have 30, not assume, but it's actually the 30 kilonewton meter bending moment over here. So it is a horizontal line, again it has to come in, this has 0 degree, 0 degree line, it has to be a 1 degree line, a straight line with a constant slope. From here to here, no shear force. As we saw that when there is no loading, the shear force diagram has to be horizontal, and then the bending moment is going to be straight line. So when there is no shear force, the bending moment diagram is going to be a straight line like this. So again, here it was 30 Newton meter, here it will be 30 Newton meter. So this box, its area is again 10 multiplied by 30, but it is in negative, so it will go downward. And from here to here, it will go downward because in a straight line, because it is horizontal line. So this will give us uh, the bending moment diagram for this beam. Again, here you have to start with this beam. First, we need to find the reactions. As you know, the reaction is easy. This is a 10 kilonewton per meter. When we multiply 10 kilonewton per meter by 10, it will be 100 kilonewton force right at the center, and it will be divided equally to both the supports. So it will be 50 kilonewton to the right support and to the left support, and 50 kilonewton to the right support. So the reactions are found. Now we have to draw the shear force diagram. This is the zero line for the shear force diagram. And again, we have a 50 kilonewton force going upwards over here. So this is 50 kilonewton force. And from here to here, we have one kind of loading. It is 10 kilonewton per meter load distributed from this, from the left to the right. From the left to the right, we will find the shear force by measuring the area of this load diagram. The area of this diagram is, its height is 10 and multiplied by 10, so it's 100. So 100 kilonewton, we have to go downward because it's pointing in the downward. So from this point, if we go 100 kilonewton, we will reach the negative 50, because from here to here it's 50, then again to the negative 50. But it is from the left to the right. So from the left to the right, we have to go to the negative 50. Here it will be minus 50 kilonewton. But how we have to proceed from this 50 to this negative 50 kilonewton shear force? It will, the loading diagram will tell us. It is a horizontal line, so we have to, it has 0 degree. So we have to go in a linear way with 1 degree line. So it's gonna be something like this, and this degree is, this is a 1 degree line, linear line with 1 degree. So this is the shear force. Again, from here it will be uh, 50 kilonewton, over here it will become 0. So now we have to find the bending moment diagram for this beam. As we know, this is the zero line for the bending moment diagram. The bending moment will be 0 at the pin and the roller support at both these ends. So from the shear force diagram, we have to find the area of this triangle, but we first need to find the value of this dimension, the base of the triangle, which can be easily found from the slope of this line. The slope of this line is equal to vertical divided by horizontal. So the slope is equal to, this vertical direction is, as you can see, this vertical direction is 50 from here and 50 from here, so it's 100, and the horizontal direction is 10 meter, so it's 10. So the slope is equal to 10. Now if we want to find this x, we can easily find that by doing slope equals vertical 50 divided by x, horizontal is equal to, slope is equal to 10, so x will be 50 by 10 equal to 5. So in this case, x is the length, so it is in 5 meters. This length will also be 5 meter. We can assume that this will be 5 meter because it's symmetrical loading, and it will definitely pass through the center, so that can always be guessed. So in order to find the bending moment, we find this area. So this area will be, the area of this triangle is equal to 1 upon 2 multiplied by base 5 multiplied by 50. So it's like 250 divided by 2 is equal to 125. So here it is 0 bending moment, and at this point it will be 125 kilonewton meter. And from here to here, since it is a straight line, 1 degree line, we have to go in a 2 degree line, a curved parabola. So this is 2 degree line. And again from here to here, the same 125 will be, but it will be decreasing because it is in the negative portion. So it will go to the 0 portion, and that's how we can find the bending moment diagram. So thank you so much for watching. I hope you loved this video. In the future series, we will be making videos regarding the fixed beam, uh, cantilever beam, overhanging beam, continuous beam, and under different load conditions. So I hope you enjoyed this video. Subscribe to the channel, like the video, and I will see you soon in the future videos. Thank you so much for watching.